So this is the hierarchical model for the anarchic manufacturing system final year project. Using the AnyLogic simulation platform where I can build an agent-based model. And here I've built one for the hierarchical system. I'm using 5 machine tools here, 2 with capability A, 2 with B, and 1 with capability A and B. The jobs, as you can see, arrive into the waiting area, and then on assignment to a machine tool they move towards them, and when they finish their job they turn blue, when they finish more than one operation, and when they're idling waiting for their operation of the machine tool they are orange, and when they finished a job, finished all their operations required, they are purple and they move towards the ship area. So the jobs are scheduled hierarchically. This is done through the scheduler, and they are scheduled in a FIFO logic on their arrival to the scheduler itself. It will schedule the first job in its list to the next available machine tool with the same capability, and then it will iterate through that list. This is for jobs that are not being currently operated on. So that's those who are freshly arrived, as well as those in the waiting area and the ones waiting in the queue for the machine tool themselves. So we just pause it for a moment. We go into the agents. So this is the job agent. Here it starts off waiting to be allocated in waiting area, and when it has been allocated it moves, queues and operates on. It evaluates how many job operations remaining, and then we'll move back. You see here this is color coordinated. So this one here has just completed all its operations required, so it's 3 required, and it's completed 3 and it's moving towards the ship area. So this one is just been allocated, it's moving towards the machine tool that's been allocated, which is number 5. And it's the operation that is required to do. So on. So if we go back to the main and go on to the machine tool, this one for example has 3 main states: idle, working and failed, and it has 2 jobs currently in its queue, so 1 being operated on and 1 other one waiting. The utilization has been recorded and some other features. So a reschedule can be called when more than 20 jobs are waiting in the waiting area, or a machine tool has only one, has a queue of 0 and 1 in its system, so 1 being operated on, or there's jobs waiting in the waiting area and the machine tool is idle and has 0 in its queue. It can also be called on special events, for example machine tool failure. In a moment the machine tool 4 here is going to fail, it's going to turn red, and then it's going to be called a reschedule, which the jobs will then move around so that to be best allocated according to the scheduling algorithm. So now the jobs will not be assigned to machine tool B now it's failed, and on its repair it will record a reschedule as well.